Uh, Hello everyone. Today we are going to start session 4 where we will discuss about circuit fabrication, circuit design, circuit fabrication, uh, simulation, circuit simulation, etc. So previous three sessions we have discussed electromagnetic levitation of spherical object, electromagnetic levitation of flat plate, electromagnetic levitation of C-shaped plate. We have seen that there are three type of attraction electromagnetic levitation. One is attraction type, repulsion type, and superconducting magnets. So we are discussing on attraction type electromagnetic levitation, where one force is in upward direction, coil force is in upward direction, and mg is in downward direction. So it's an open loop unstable system, and the system is highly nonlinear system because air gap versus position is highly nonlinear. So for to design the controller, we need a nonlinear controller or linearized controller. So what we have discussed till now, that is the linear controller. Okay, the system actually was non-linear. We have linearized the model at a particular operating point, desired operating point, suitable operating point, and then using Taylor series expansion, linearized model has come. And then on that linear model, we have put all the parameters at the operating point, and then we got that transfer function, and then modeling, stability analysis, etc. starts. So basic point of levitation is to design the electromagnetic levitation prototype. They have many steps. First was that selection of the object, shape of the object, mass of the object. That is the first important first task. Second thing is that to select to design the coil design is the second part. And third, once the coil design completed and the object is ready, then we have to make a mechanical structure, mechanical frame, because frame we require spirit level accuracy and true mechanical zeros setup. And once third step is completed, then fourth step is electromagnetic analysis using FEM software and sys Maxwell. And then from electromagnetic analysis we will get clear idea about the flux density, flux intensity, all the nature flux nature we will get from the electromagnetic analysis. And then after getting the electromagnetic analysis, fifth step is parameter evaluation. So we'll get all the parameters from simulation, practical, and if possible from analytical model. Analytical model is based on mathematics, calculation of the cross sectional area of the flux lines. So analytical model if possible. So by three possible ways we can get the plots of parameters. And then sixth point is that once we have got the parameters, then we'll do modeling. We'll start the modeling. So in modeling we'll see the mathematical equation, and then we'll linearize the model at a particular operating point. So after linearize the model, we will get the small signal model at particular operating point. What would be the best operating point? That would be selected from the inductance plot. From inductance plot we will take one possible point where stable levitation is possible, and that point we will linearize the model. After linearizing the model using Taylor series expansion, we will get the linear model. Then taking Laplace transform, we will convert from T domain to S domain, we will get the transfer function. And seventh point is that after getting the transfer function, we will do stability analysis, and we will design, because the system has a one unstable pole at the right side of the S plane. And then modeling is completed, Now we will design the controller using MATLAB Simulink. Okay, and then once the controller works perfectly, then we will go for the uh, circuit fabrication. Before going to the circuit fabrications, there need to check by simulation using PSpice, Orchid or SQL. We'll have to check exactly what we required output that is coming or not. And after validation through simulation, circuit simulation, then if it works, then we will go for the fabrication through breadboard, board, etc. Then testing will come. If the circuits work properly, then the will do testing on circuits. Okay, in breadboard or board, and whole closed loop system control will now work. And if it satisfies, then we will go for the PCB design. PCB is fixed. It will be if it will be fixed with the practical setup, and then it is fully completed. Okay, so these steps we will have to follow, and we will use six simulation softwares to fabricate this prototype. Okay, so first software we required for electromagnetic analysis, we required ANSYS Maxwell. System modeling, we required MATLAB Simulink or Scilab. Then for controller design, circuit simulation, we require PSpice or Orchid or SQL. And last, for PCB design, we required Express PCB software. These 6-7 softwares we required to complete the process. Okay, now I will directly go to the circuit design. Circuit design is at the last step. Okay, last step before testing. Last step is actually PCB design, but before PCB design and testing, the circuit design is important. So circuit circuit design and circuit simulation, they have difference. After getting satisfied result from circuit simulation, then we will fabricate this on breadboard and board. So I am directly going to the circuit fabrication. So we have suppose we have designed the controller in MATLAB and MATLAB and Simulink, and then how we will go, because we are working on analog controller. Okay, so how will we go from block diagram of MATLAB to the circuits? Okay, so that topic I will discuss today. That is very important topics, because these all are about to practicals. Okay, now you can see, suppose I can yes, suppose you can see here that this is the block diagram. Okay, uh, okay, this is a one block diagram. Okay, this is in closed loop control system. So you can see that there have the you can see this is the mechanical system. Okay, this is the electrical system. Okay, so in the mechanical system, please see one pole is in the right hand side of the S-plane, but in electrical system there are no right hand side pole. So the system is unstable because of the mechanical dynamics, but the system is electrical plus mechanical, so electromechanical system. So this is overall electromechanical system. Okay, now for electrical systems, we have designed this current controller. Okay, inner loop. And for position mechanical dynamics, for position control, we have designed this lead capacitor using MATLAB and Simulink. And keeping in mind that we have kept the gain margin is 60 dB, and phase margin is 30 degree. Phase margin is 30 degree, because it's a frequency analysis. In frequency analysis, this is the Thompson rule, that the gain margin should be 60 dB and phase margin should be 30 degree, the best control uh, criteria. So this we have, now I am directly going to the uh, okay. Now so this has been designed by MATLAB or simply. Okay, now we will have to design this controller, means this whole circuits except okay, except this is the mechanical, okay. uh, this is the system actually. This is the electrical part and this is the mechanical part. So electromechanical part. Now this is the real system, practical system. So but rest of the part we need to fabricate. Okay, so we'll have to fabricate this is the feedback actually, sensor feedback. So but main is this controller. Okay, so PI controller is in the inner loop and outer loop there have the lead capacitors. Now I will discuss how we will go to the uh, mm, how we will design the circuit from this block diagram of MATLAB. Okay, how we will design the circuit. Now I am going to the circuit design. Okay, before going to that we require, you can clearly see this circuit. Okay, uh, you can clearly see this is the circuit. You can see this is this is the subtractor. Okay, because we need one reference and one feedback coming from the outside, we require to subtract, that is the subtractor. So error will be generated here. Okay, and this is the lead compensator that has been designed from the MATLAB. Okay, now again this is the subtractor. So two loops of control strategy. So two loops are there. So one is first, this is on the first, second subtractor, and again they have the PI controller in inner loop. Okay, so PI controller, and these are the feedback in the inner loop and this is the feedback in outer loop. Now I will tell you that how. So if you check the uh, uh, transfer function of this lead capacitor, it will come as 4 into s plus 45 by s plus 450 something, it came in MATLAB. So if you check the transfer function of this op-amp based circuits, op-amp based lead capacitor, you will see it transfer function will come this. Okay, so using trial and error method, we will put the values of resistances and capacitances. Okay, using trial and error method, we will choose the resistance value, capacitance value, such that it comes as 4 into s plus 50 by s plus 450. So in the lead compensator, you can see that we have used one non-inverting amplifier. Okay, this one is a non-inverting amplifier and one inverting amplifier. So you should have a clear concept about the amplifier. huh? Of the non-inverting amplifier, we will get the output equals to 1 plus Rf by R1 into input, and in inverting, here the output is minus Rf by R1 into Bi. So this is the, so if you calculate the total transfer function, if you calculate total transfer function, it will come as this: 1 plus Rf by R1 into S plus 1 by R1 C1 by S plus R2 by C2. Suppose from MATLAB the transfer function is coming a 4 into S plus 50 by S plus 450. Suppose. So you can choose the value of Rf by R1, 1 plus Rf by R1 as 4. So you will get the Rf value and R1 value. Similar way, S plus 1 by R1 C1, there have the 0. So S plus 1 by R1. So S plus 1 by R1. 1 by R1 C1 equals to 50. Then you will have to choose the value of resistance and capacity R1 C1 such that it comes as 50. Same way, 1 by R2 C2. S plus 1 by R2 C2, they are have the pole. So that is coming from MATLAB, that is 450. So 1 by R2 C2 equals to 450, and you will have to choose the resistance capacitance value accordingly. By this way you will have to design the circuit. Now now these all are the LM324 op-amp. Okay, you can use the TL084 op-amp. Okay, so there the properties are different. You will have to check from the data sheet what is the operating point, etc. So generally in LM324 there are 4 op-amp available on one IC. In one IC there are 4 op-amp are available. As for one op-amp there require 2 input and 1 output, 1 plus non-inverting and inverting minus and 1 output. So 3 into 4 means for 12 pin. 12 pin, 1 pin is for plus VCC and 1 pin is for ground or minus VCC. So this 14 pin IC. So LM324 is 14 pin IC where 4 op-amps are available. Okay. So whenever we are doing these circuits, so data sheets are very important. From the data sheets we have to see the operating point, etc. Now I will go to the, so these are ICs LM324 or TL084 we can use. Okay. Here also you can see that the gain was 1000 and in the MATLAB. Okay, so actually this 1000 feedback that is coming from the sensor. Okay, sensor sensitivity plot we are getting this, but additionally also we can put small amount of amplifier gain like this with the feedback. Actually this part should not be actually. It is because the feedback gain is already inside the sensor or transducers. Okay, we no need to add extra, but for this purpose, actually for fine tuning we require these type of things. Okay, for parameter from parameter uncertainty is an issue here, so we'll have to use some extra features, okay, such that we can adjust if there have some error arises, this type of. So this is the current sensor feedback. Okay, means this is not the gain of the current sensor, but additionally small amount of gain has been added with the current sensor gain for fine tuning purpose. And this already I told you, subtractor error will be generated here, then it will go to the lead compensator, and then inner loop starts. This is the second subtractor, inner loop start, and then this is the lead PI controller in the inner loop. So one thing you have to remember, this loop should be faster than the outer loop, because actuator is in the inner loop only. Okay, so inner loop should be act fast, loop should be faster. So this uh, is important. Now please see that 3 number pin, this pin is coming from the current sensor, and this pin is coming from the position sensor. Okay, now watch this pin. Yeah. Now watch this pin, this pin, 8 number pin. This pin, this pin is the is going to the driver circuit. This pin will go to the driver circuit, which will drive the coil current. Okay, now still now the loop has not been completed. Actually, two feedback is coming, we know feedback is coming, and then where this point will go, this point will go to the driver circuit. I'm going to the next circuit. Okay, you can see the driver circuit. This is the driver circuit. Now you can see this is the driver circuit. uh, okay, this is the driver circuit. Okay, you can see this point is coming from the 8 number pin. That pin is connected with this. Okay, uh, now you can see. Okay, so this that pin is connected here. Okay, now you see the coil is connected here with 42 volt. You can see this, the 42 volt connection is there, and next. Here you can see that 42 volt is connected with the coil. Okay, plus 42 volt, and this pin is the 8 number pin, it is coming. Okay, that is, and now this is a Darlington pair circuit. So finally transistor is driving the coil current, required coil current. So this current we need 0.9 ampere for flat plate. Okay, this so 0.9 ampere we already know, it is coming from the current air gap plot. Okay, so this current we required at stable levitated position. So this current, who will provide this current, who will provide this current? uh, this transistor will provide this current. Okay, all the time, means at stable position, when the plate has been stably levitated, it will provide 0.9 ampere at coil. Okay, so before that I'll have to discuss a few things here. uh, few things here. Okay, so this is a Darlington pair circuit. Now this point is coming from the, this point is coming from the current controller. Okay, current controller it is coming. Now it is going through the Darlington pair circuit, and this current we need 0.9 ampere at stable levitated position. So you can see that before that we should know the property of the transistor. So transistor is operating as a linear amplifier here. Okay, transistor is operating as a linear amplifier. So you know the transistor operates as a linear amplifier or cutoff and saturation zone. Here this transistor is working as a linear amplifier. So what will happen, and when there have no base current, the transistor will be off. So will be off. So full voltage 42 volt we will get between this point. Okay, transistor is off, so 42 volt we will get through this. Are you getting my point? So 42 volt. Now so current is 0 here. So current we will get 0 when the switch is off. When switch is off we will get full voltage here, so coil current would be 0. Now suppose the setup is working in closed loop control, we will get few amount of voltage, sorry, few amount of base voltage here. So current will start to flow, means the switch will be on gradually. Just the we'll have to see the property of the transistor. So cutoff zone, active zone and saturation zone. Okay, this is the property of the transistors. So this property, and now we'll have to choose the transistors, practical transistors. So there are lots of transistors: CL100, CK100, NPN, PNP transistor, CK100 is PNP, MJE13005 is also NPN. Now what is our desired requirement? According to, we will have to check the data sheets of the transistors. There are lots of transistors and we will have to pick up on transistors that fulfill our characteristics of the, because we need 0.9 ampere and there have lots of things, the base emitter voltage, cutoff saturation, and there are in data sheets everything is provided. Okay, now it will start to flow current when it will get a few small base voltage. Okay, so second, now see that it will start to flow current. Okay, when the transistor is on, means it is getting small amount of base voltage. So gradually it will increase, it will follow the properties of the transistors, but we will operate the transistor as a linear amplifier, not in active or saturation zone. Okay, so it is not coming. Please see the transistor will, it is not working, I think something's wrong is happening. So then we'll have to select the transistor according to that, and you can see there have one CL100 transistor. One second, something problem is doing here. You can see that one CL100 transistors is there. So this CL100 transistor is NPN transistor. This is also NPN transistors. One freewheeling diode is there. Okay, freewheeling diode is there. And emitter resistance is we have kept 1 ohm. Okay, this is 1 ohm, and freewheeling diodes 2 IN4007, we have used CL100, CK100. So these all properties we will have to check in data sheet actually, which matches with our requirement, and then we will have to select that transistor for. So this is the driving circuit, because we require to control the coil current. So at the driving point we need a driving circuit to in the driving circuit, coil is connected. So the we can tell this, that the controller output is coming here, and this is the full driving circuit which will drive the coil current. Our desired current is 0.9 ampere. Okay, and feedback, we know feedback is coming from the mechanical system, and current feedback is coming from here, current sensor. Okay, so current sensor we can add uh, through coil we can with series. Actually, with series we will have to connect the current sensor, and then it will go to the feedback for inner loop feedback. Okay, and position sensor is mechanical, that is coming from the, then it will be closed, full closed circuit. Now I am going to the different type of weighted gain combination approach. There are lots of things, and these are not required. Okay, yeah, so already I told you that we have seen that these are the op-amp. Okay, these are the 1 op-amp, 2 op-amp, 3, 4. Suppose these four op-amp will be available on one IC. In one IC, one op-amp is available. In one IC, four op-amps are available. 14 pin IC. So you can see that 14 pin IC LM324 or LM324 14 pin IC. You can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 14 pin. Okay, so 1, 2, 3 is one op-amp, 5, 6, 7 second op-amp, 8, 9, 10 pin is the third op-amp, 12, 13, 14 is the fourth op-amp, and 4 is connected with the plus BCC, and 11 is connected with the minus BCC or ground. Okay, here it's a 11 point is ground, because we are working on the DC signal. Now you can see by this way we will have to connect the circuit from block diagram to op-amp and op-amp to IC. So first step, we started from the MATLAB. We got the transfer function block diagram, and then we put it in through op-amp. Okay, so that is the op-amp based circuit we design, and then finally we are going to the ICs, and this is the IC LM34, where 4 op-amps are available. 4 number pin plus and 11 number is minus. By this way we will have to design all the circuits, we will have to connect all the circuits. Now once it is completed, okay, before that also we did one mistakes, and then after getting this we will have to simulate it in PSpice or SQL. Okay, we will have to simulate it. If it satisfies, if it satisfied, if it what we required, if we achieve that, if it is desired output is coming, at desired output is coming, then we can go to the practical to fabricate the practical circuits. Okay, this is the starting point to fabricate the circuit, where for ICs are available. We will have to connect that, and then we will have to soldering in the components, and then if these circuits also work properly on the breadboard or board, then we can go for the PCB design. Before going to the PCB design, we'll have to test the circuit. We'll have to, there are no simulation kind of things in Express PCB. There we can the pin. Okay, because the in PCB, what is the advantages of PCB? In PCB, the advantages is Where it's a block diagram. Sorry. So in PCB, the advantages is the size is very less. Okay, but uh, before that we'll have to make the design of PCB in Express PCB software. Then final fabrication of the layers of the PCB. If it is double layer, then top layer, bottom layer, this type of things are there in Express PCB. Then finally PCB is done. Then it would be fixed with the practical setups. He also test the electrical circuits in Simulink also. In Simulink also, before going to the analog circuit design, we can design the circuit in Simulink. Then if simulation is okay, then we can go for the circuit uh, design, and then piece-wise or sequel we can then piece-wise or sequel. Okay. Next day also we will discuss about the circuit fabrication. It's a very important part because now we have come on the practical circuits. Okay, so analysis has been done, modeling has been done, stability analysis has been done, and circuit fabrication has been done. Sorry, circuit simulation has been done, and then circuit fabrication has been done. Express PCB has been done. Now we will test the circuit with associated circuits and we will take the waveforms. If it stably levitated, we will get a stable current 0.9 ampere. Transistor will provide this. Okay. Otherwise, the system is actually unstable system. So either it will touch the coil or it will fall down. When the everything will work properly, controller will work properly, the system will be stable. And at the last step also we require for fine tuning. There have some parameter uncertainty. Maybe parameter uncertainty, actually parameter uncertainty will come arises, though we have taken perfectly, we have designed perfectly, we have done we have followed all the steps, but still there may be some parameter uncertainty. For that purpose we require fine tuning. We'll have to keep some additional part of the controller in the controller in desired position. There are a few positions where we can add this we can add pot in the place of resistances. We can place few pots. So suppose if we use resistance in the lead compensator, solar resistances, suppose, uh, then we have no provision to change the resistance actually. Then we'll have to make the soldering. We'll have to remove the soldering. Then we'll have to do that is very uh, risky. So better to use some pots if fine tuning is required at the last step. Then it completes. And next day also we will discuss about the circuit design and fabrication. Okay, thank you.